Alright, so this video here, let's take a look at the law of cosines. Alright, so here's our formula for the law of cosines. We have a squared equals b squared plus c squared minus 2bc times cosine of a. Alright, so let's draw a little picture of a triangle. So let's say that here's angle A, here's angle B, here's angle C. Now side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So you don't really need to memorize all the formulas. There's a pattern to them. You see how we have the A squared and or side A squared and angle A. See, here's the angle, here's the opposite side. So if you have A here, the side A here, and the angle opposite you're taking the cosine of, well, then it's just the other two sides squared and add them together minus 2 times the other two sides. Okay, so just like here, this side is opposite this angle. So side B is opposite angle B. Well, there's angle B, there's the side opposite. So it's the other two sides squared, add them together, minus 2 times the other two sides times the cosine of B. And that's the pattern for all of them. So that's really what you need to remember. Excuse me. Now, what I want to say about the law of cosines is whenever you're solving these triangles, obviously you're going to be working problems and you'll have these triangles in. Some of them you'll use the law of sines on, some of them you'll use the law of cosines. The easiest way to remember this is always use the law of sines, okay? Unless there's no other choice and you have to use the law of cosines, okay? So only use the law of cosines when you have to. Alright, now you should be familiar with the law of sines, and you know when you solve the triangles using the law of sines, there's that possibility of two triangles. Okay, you can either have 0 triangles, 1 triangle, or 2 triangles. Okay, and when you're working the problems, always use the law of sines. Only use the law of cosines when you have to. And if you have to use the law of cosines, there's not going to be a possibility of 2 triangles. You're only going to have 1 triangle. Okay, so the possibility of 2 triangles is only going to come up when you can use the law of sines. And I have some videos on law of sines. You can check those out. Alright, so let's go ahead and get started on our first problem. Alright, so the first thing that I like to do is I just make a table of what I want. So I've got my angles, my sides. So I've got angle A, which we know is 41.4 degrees. I've got angle B, I don't know that. Angle C, I don't know that. Side A, we don't know that. Side B, that is 2.78. And side C is 3.92. Okay. Now, if you recall the law of sines, it is the sine of A over A equals the sine of B over B equals the sine of angle C over side C. Now here you can see that we cannot use the law of sines here. See, if I plug in sine A, if I plug in the 41 here, okay, the only other values I know is I know B and I know C. So if I set this equal to this, well, I have 2 unknowns. If I set this one equal to this one, I have 2 unknowns. Or if I set this one equal to this, I have 2 unknowns. So we can't use the law of sines, but that's what you always want to check first. So now that means I have to use the law of cosines. So looking at this, you can see that we know angle A, we know B and C. Okay, we know B and C. So the only unknown is A. All right, so look at this. See, we know B, we know C, and we know angle A. So we can solve for side A. All right, so let's go back to our problem. So I've got A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of A. And so that's going to give me A squared equals, and I'll have to punch all this into my calculator. Alright, so I get A squared is 6.75. I rounded it to 2 decimal places. And so that means A is equal to the square root of 6.75, which that gives me 2.6. Okay, so I get A, side A is 2.6. Okay, so that gives me side A. Now I need to solve for angle B and angle C. Alright, so doesn't matter which one well, it makes a difference which one I solve for. It's going to make it easier on us. So let me go ahead and erase this. So now I'm going to use the law of sines. Okay, and I'm going to solve for the smaller angle first. Okay, so you solve for the smaller angle, and the reason is because if I solve for the smaller angle first, I know angle B is between 0 and 90 degrees. Okay, because angle C is my largest angle. Okay, angle C is my largest angle. So if I solve for C, when I take the inverse sine to solve for angle C, it's going to give me an angle between 0 and 90 degrees. It's going to give me an angle in the first quadrant when I do the inverse sine. But how do I know that angle C would not be the angle in the second quadrant? Okay, so what we do is we solve for the smaller angle first, and then we just do 180 minus angle B minus angle A, and that gives me angle C. Okay, so what I'm getting at is if you solve for C first, the largest angle, you don't know if it's the first quadrant angle or the second quadrant angle. Okay, so make sure you solve for the smaller one first, because we know this angle is in the first quadrant. Because there's no way it can be in the second quadrant, because if it were, then that means angle C would be in the second quadrant. Okay, and you can't have two angles in the second quadrant, because when you add them together they would be more than 180 degrees, and that would not be a triangle. Okay, so let's solve for angle B first. So that's the sine of 41.4 degrees over 2.6 equals the sine of B over 2.78. And so I get sine of B is equal to 2.78 times the sine of 41.4 degrees over 2.6. And so I get sine B is equal to, and then we'll have to punch this into our calculator. Okay. So I get sine B is this, and then I take the inverse sine, So I get B is, well, that's 45 degrees when we round it. Okay, and so this is 45, oh, is 45 degrees. And so now to get angle C, well, C is just 180 minus 41.4 minus 45. So C is 180 minus 41.4 minus 45, which is 93.6 degrees. And so I get 93.6 degrees. And you can see that C, okay, C is in the second quadrant. But if I would have solved for C first, and when I got to this step here, if I would have had sine C equal something, and then I would have taken the inverse sine, I would have gotten C is equal to, and that would have been something in the first quadrant. Okay? So, and it would have been incorrect. That's why we solve for the smaller one first. Okay? Because now we don't have to make the decision. This right here, doing 180 minus these two angles, tells us if C is in the first quadrant or the second quadrant, and in this case it was in the second quadrant. Alright, so hope that made sense. Alright, now let's look at the second problem. Alright, here we have, they give us three sides. So let me make my table up. I've got my angles and sides. So I've got angle A, we don't know, angle B, we don't know, and angle C, we don't know. So A is 28, B is 47, and C is 58. Okay? Alright, so obviously here you can see we cannot use the law of sines. So we have to use the law of cosines. Now, the easiest way for this one is whenever you have to use the law of cosines and they give you all three sides, solve for the largest angle first. So in this case, we'll solve for angle C first. Okay, so I'm going to use the formula. See, I'm looking for angle C, so you can see I know A, B, and C. I can plug all that in and solve for angle C because I know side A, side B, and side C. Alright. Alright, so I have 58 squared equals 28 squared plus 47 squared minus 2 times 28 times 47 times cosine C. Alright, so now I need to solve for cosine C. So I'm going to subtract 28 squared and 47 squared to both sides. And so that's going to give me 58 squared minus 28 squared minus 47 minus 47 squared, and that equals negative 2 times 28 times 47 times cosine C. And then we're going to divide both sides by negative 2 times 28 times 28 times 47, and that will give me 58 squared minus 28 squared minus 47 squared over negative 2 times 28 times 47, and that equals cosine C. And so this gives me cosine C is equal to, and then we'll have to punch this into our calculator. Okay, so we punched that into our calculator, And notice here how I get cosine C equals a negative number. Okay, so remember, all students take calculus. Okay, so cosine is a negative number. I know there angle C is in the second quadrant. And when I do the inverse cosine of this number, it's going to give me the angle measure in this quadrant. If I would have put all this in my calculator and it would have been positive, then I would have known that that angle measure would have been in the first quadrant. Okay, so we solve for the largest first, and the law of cosines will take care of that and will let us know if it's in the first or second quadrant. If I get cosine of the angle equals a positive, I know that angle's in the first quadrant. If I get cosine of that angle is negative, then that lets me know it's in the second quadrant. So I do the inverse cosine of that number, and that gives me angle C is 98.1 degrees. Okay, so angle C is 98.1 degrees. Alright, so now I can solve for angle A or angle B using the law of sines. Alright, now which one should I solve for first, the smaller or the largest? Well, really it doesn't matter because I know angle B and angle A are both in the first quadrant. Okay, angle C is in the second quadrant, but even if angle C was not in the second quadrant, I would still know angle A and angle B are in the first quadrant because this is the largest angle. These two angles that are smaller than C, they have to be in the first quadrant. Okay, so it really makes no difference which one I solve for first, but I'll go ahead and solve for angle A first using the law of sines. So I'm going to go ahead and erase all this work here for the where I calculated angle C. Alright, so let's solve for angle A. We'll use the law of sines. We'll use this and the angle C inside C. So the sine of A over 28 is equal to the sine of 98.1 degrees over 58. So sine A is equal to 28 times the sine of 98.1 degrees over 58. So I get sine A is, punch this into my calculator. Alright, so I get sine A equals this, and so angle A is the inverse sine of this, so the inverse sine of that number is 28.6 degrees. And that's rounding it to one decimal. 28.6 degrees. And so now angle B, that is just 180 minus these two angles. So angle B is 180 minus 28.6 minus 98.1, and that is 53.3 degrees. So that's 53.3 degrees. Okay, so to recap, only use the law of cosines when you cannot use the law of sines. Okay, so here's the case where we were given an angle and two sides. Okay, so we solve for the side opposite this given angle first, and then we solve for the smaller angle. Okay, next we were given three sides, and we solve for the largest angle first, and then we use the law of sines to solve for the smaller angle. Alright, so hope this helped. Don't forget to like and subscribe and check out my other videos. Alright, thanks.